All right. Sorry. So let me get my little drawing pad. Sorry, I should have been hooked up, but it's easy. So, just a couple things before the test tomorrow. A couple of you guys said that you watch my videos every now and then, so I'll just put this in the Teams chat. But anyways, this isn't too bad. This is one of the reviews. I don't think I gave this one to you guys, so it'll be fresh. In any case, for the test, we'll be talking about dot plots, mean, median, range, lower quartile, upper quartile, IQR, and then a little bit of box plot stuff. And it's really not too bad. So let's talk about it. Sorry, I live on a loud street. So, for example, an example of a statistical question. Remember, a statistical question, it has to be something that's useful to get information from a group of people. So it can't be about one person. So, about one person. And so we don't really care if it's like, oh, what does Jane feel about this? Another thing is it has to have many options. Has to have many possible answers, right? Possible, I should say. Can I spell? So it can't be something like, oh, does Jane have a dog? But that's not a statistical question because we don't care about Jane, and it's just a yes or no. Does she have a dog or not? So A would be, because A is just a factual thing. All right, how many states are there? What is the capital city? Again, it's just a fact. How tall is the average NBA player? That is the answer. I don't love that. This is kind of one of the reasons why I didn't do this review. But we could ask a lot. In fact, I would argue that none of these are statistical. If I had to say one, I would pick C. But none of these really, these are all just kind of fact questions, right? There is a de facto largest city in the world. There is there is like an average, right, in the NBA. So I would actually argue, I'll give you an example. How many hours did you sleep last night? Right? That's a really good statistical question because it's not just about one person. Anyone can answer it. And it has many, many possible answers. You wouldn't believe the answers that I get when I go around and I ask people, how much did you sleep last night? It's crazy. And I guess this is the answer to number 2, right? Can't be about one person. It has to have many possible answers. Mrs. Kelly asked her students to plot the number of books they read over the summer. Using the dot plot to the right, what was the total number of students that plotted the number of books they read? This is just the total number of dots. Total number of dots. And so we could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 students. But that reveals a lot, right? So remember, the title kind of corresponds with these numbers down below, right? So, for example, we could say 1 student read 0 books. 3 students, right? So 1 student read 0 books. We could say 3 students read 1 book. I could say 6 students read 2, and so on. That would be the frequency of each of these data points. 1 student, and then 2, and so on, right? So if I were to list this data out, there would be 1 0, there would be 3 1s, there would be a bunch of 2s, 6 of them. There would be 2 3s, and so on, right? So the peak, of course, would be 1, right? That's the highest frequency, right? So The peak is the highest frequency. Often sometimes referred to as the mode, right? But this is our answer. But if you ever are looking for a peak, you just want to look for the tallest value, right? And then we're actually not going to talk about spread. Spread, it is super easy. It's just, in this case, 0 to 5. It's wherever we have data. It's very similar to the range, though. And I think the range is a better measure of spread. It's more useful. So number 6, 7, 8. What is the median for this dot plot? There's a couple ways we could find it. Cross off dots in pairs. So cross this one off. So I'm going to start from the bottom on the left and work my way up. And pairwise, so simultaneously, I'm going to start from the top on the right and work my way down. So boom, boom. So in pairs. 1, 2, 1, 2, 1, 2, 1, 2, and so on. It's very simple. And we see that we have 1, 3, and that is our median. And we could do the same thing here, right? So this is just the data listed out. Again, in my opinion, it's a lot uglier. It's a lot harder to see what's going on. So that's why we use dot plots. And to be completely honest with you, there's our 3. To be completely honest with you, it's just it's a really good way to develop like a habit of mind. Like, how do we actually view these things? Like, how does data actually how is it distributed, right? Let's look at number 7. Which is a true statement about the dot plot? There are 11 players on the team. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, yeah. Lucky. A was our answer. How did I find that out? Well, remember, the title corresponds to these numbers, right? So we have 1 10-year-old. Right, oops, sorry. Didn't mean to do that. We have 1 10-year-old. We have 3 11-year-olds. We have 0 12-year-olds. 2 13-year-olds, 1 14-year-old, and 4 15-year-olds on this soccer team. Right, and so if we add those numbers together, 1, 4, 6, 7, 7 plus 4 is 11. I just added all the dots together, right? This one's tough. This one we just have to find the median of both data sets. So look how easy this is. Right? Just work my way into the middle. Right? I don't want you guys losing points over stuff as simple as this. Notice how I have just a bunch of 2's left. So I know the student median is 2. Let's find the median for teachers. Boring. I have 2 left. They are both 3. So for teachers, it is a median of 3. So the median for the students is 2, and the median for the teachers is 3. So by comparing, it's just saying this one is this way, and the other one is that way, right? And it's just about number of siblings, obviously, right? So the median number of siblings for for students is 2. The median number of siblings for teachers is 3. Okay. Okay, cool. This has almost everything that we're going to be doing on the test. So what is the mean, median, and upper or lower quartiles and IQR of this data set? So the first thing we're going to do is we are going to put it in order for the median. I guess we could find the mean first. So let's do that. I'm just going to use my phone calculator. It's very simple. So all I'm going to do is add up these values. So 17 plus 24 plus 26. Oops. Okay, so our mean is, those numbers add up to, oops, not that, 175. And we are going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. That comes out to 19.4 repeating. Like I said, I'm not super I'm not super keen on decimals, so I don't freak out if you guys get a bad decimal. But that's more the physics teacher's job, right? So like I said, let's start by putting this in order. So just scanning, I see that 13 is my lowest. 15, 16, 17, 18. 22. I have two 24s and one 26. Right, so finding the mean, the median, finding the median, the upper quartile, the lower quartile, those are all kind of the same thing in a lot of ways, in the sense that you need to find the median first before you find the lower or upper quartiles. All right, so my median is 18, so you'll see I put a big black line right there. And that splits it into two sections. Right, so I'll call this my lower half is my green section. We're going to use that to find the lower quartile. And my blue section is my upper half, so we'll use that to find the upper quartile. And so we're just going to find the median again. And you'll see that we have two values in the middle. And so we're going to find the middle of that. So what is exactly halfway between 15 and 16? Well, that would be 15.5. And again, if you accidentally put 15.5 over here, I probably wouldn't knock you off. Like, you know what you're doing, you just misread. It's important to pay attention to what you're doing, obviously, but as you can see right there, I just found the median of my upper half, the blue values. It's just, again, half. And what is in between 24 and 24? Well, it's just 24. It's funny. There's so much math behind that. What's in between 24 and 24? If you ever want to get your math major, you'll take a class called Real Analysis. And you'll learn a lot about all that. So the way I kind of like to do decimals just in my head is I'll drop this decimal down. And I'm going to do this one first. Actually, no, never mind. Yeah, I'll do this one first. 24 minus 15, that's 9. But I'm also subtracting 1/2 or 0.5 as well. So that's going to give me 8.5. So that's kind of the way I like to think about decimals and just doing them in my head. I get rid of the whole numbers first, and then it's a little bit of extra work. But that gives us our IQR. Remember, our IQR is so simple. It is just the upper quartile minus the lower quartile, which is exactly what we did. 24 minus 15.5. The range is so simple. It is literally our maximum or our biggest number minus our minimum or our smallest number. So 15 minus 7, so easy, is 8. And so what are the steps to find the lower and upper quartiles of a data set? Look how easy this is. We have to order the values, so that's always our first step. Whenever we're talking about anything like median or quartiles, it has to be an ordered data set. So that's why I'm going to cross out B. So we see with A, C, and D, just like a little test-taking strategy, we see that order the values is our first thing, which is great. The next thing we need to do is we need to find the median. And notice how C just jumps straight into lower quartile, and D finds the median last, right? So our answer has to be A. What method can be used to find the interquartile range for a set of data? Remember, the interquartile range is just upper quartile minus lower quartile. So simple. Find the difference between the upper and, wow, look at that. It's right there. Find the difference between the upper and lower quartiles. All right, so for example, on number 13, if I wanted to find the IQR, here's a way, if we have a box plot, that we can find the IQR. This is my upper quartile is right here. I'll do it in red. So my upper quartile is 6, which I guess is the answer to that question. But let's talk about it some more. Our lower quartile is 3. So 6 minus 3 is 3. And check this out. Remember, the interquartile range is just the length of this box, right? So watch. If I start at 3 and I go 1, 2, 3, oh wow, look. It is 3 units long. So the IQR would be 3. I know this question is not asking for that, but I'm trying to cram as much information as I can in this little itty bit. Just one more question. One more question about box plots. So which statement is true about the box plots? Let's see. Well, we have to do quite a bit of work. So let's find for Mark, let's find some statistics. And for Sue. So the range, I'll just do R for range. The range for both of these, let's like test number A. Let's see if either of those are true. So the range would be, for Mark's class, it would be 10 minus 1, which is obviously 9. So Mark's range is 9. The range for Sue, again, just maximum minus minimum, is going to be 12 minus 3. And that is also 9. All right, so let's do some test-taking strategy. I know that B is not correct because it's saying the ranges are not the same. And we know that they are. We know that the ranges are both 9. So I know that B can't be our answer. And similar with C. C is saying their ranges are different. We know that's not true. We know that they're both 9. Right? So it's between A or D. And let's find the IQR. So let's see. We go 1, 2, 3, 4, 5, 6 for Mark's class. IQR for Mark's class is 6. The IQR for Sue's class is 1, 2, 3, 4, 5. Oh, so now these are different, right? Their IQRs are in fact different. So that was kind of the final thing that we had to find was our IQR, and we see that yes, one is 6 and one is 5. Cool. Let me do one more. Thing about box plots. So just remember. Oops, sorry. I didn't mean to do that. Just remember, it's so easy to find information off of a box plot. It's so easy. Look how simple this is. Our minimum is 1. Right? So the left value is always going to be our minimum, which we know is 1. The left edge of the box is always going to be my lower quartile, which we could tell is 3. That line in the middle of the box is always going to be our median, which we could see is clearly 8. It looks like 11, right? If we kind of drop it down, it's kind of in between 10 and 12. That is our upper quartile, which is 11, in between 10 and 12, right? And our maximum is way out here at 35. And our interquartile range is so simple. 11 minus 3 is 8. Right? And we could find that. Let's see if I can zoom in even further. I could go 1, 2, 3, 4, 5. Hold on one second. 1, 2, 3, 4, 5, 6. Why is it so? Wait, hold on. Oh, that's why. Our lower quartile is not 3. See what mistake I made there? 5. Our lower quartile is 5. So 1, 2, 3, 4, 5, 6. And we know that our interquartile range is not 8. It is 11 minus 5, which is 6. Sorry about that. And of course, that was our maximum right here. Right, so look how simple this is. In order from left to right, you can say minimum, lower quartile, median, upper quartile, and maximum. Just a little information about this box plot and why we use box plots. I don't know if there's anything on the test. I'll have to look it over once again. But I can tell you that there's an outlier here, right? We know that 75% of the data, 75% of the data is right here, contained right before that upper quartile, right? So at 11, 75% of our data is less than 11. And so there's 25% of the data that is spread out in between 11 and 35, our maximum. So it appears to me that 35 is definitely an outlier, right? And we could say that this is significantly right skewed, right? We could say it's significantly right skewed, right? Almost as if I had a list of all your ages, and then at the very end, I included my age, right? That would significantly skew the average age of the room, right? The average age of the room for you guys should be like 17, right? But I'm 31. Right? So my 31 years will significantly skew that off to the right, to the point where maybe the average age is 20 when you include my age. And we all know that that's not really representative of the data. So right skewed. And what does that mean? That means that our mean will be greater than our median. That doesn't necessarily mean that the median is a better measure of center. Again, I'm not sure if this is going to be on the test or not, but it's good information to know. The only time that we really know that the mean, is better than the median is if there's outliers. So if there's outliers, then we prefer the median. Right, that's why we use. That's why we talk about median home prices, right? Because we all know that even where we're from, there's houses that are millions and millions of dollars, but the average American isn't buying a $3 million house, right? So we don't really talk about that when we're talking about home prices in general. All right, so let me know if you got any questions. It is my job. But yeah, I hope you're ready for the test, and I hope this is just a really easy refresher. Thanks. Bye.